So we are talking about Earth's spreading floor. All right, this is section 3.2. And we've already talked about Wagner's theory that he came up with in 1912. Your book doesn't tell you that, so there's your little bit of trivia for today. And his theory, remember, was the theory of the continental drift. But even though he came up with that theory, and even after some of the scientists were starting to believe him, the biggest question they kept stumbling over was, how can these continents move? The ocean floor is solid. It can't get through them. This makes no sense. So that was pretty much the state until the 1950s and 60s. They developed some better technology. So they had better cameras, they had better ways, they had sonar, they had ways that they could actually look at the bottom of the ocean. And once that was developed, it was like a whoa moment. The ocean floor, they noticed, had mountains or ridges and cracks. So it was not a solid floor like they had thought, but it was actually had lots and lots of mountains. And these mid-ocean ridges are actually the largest mountain range in the whole world. If you look at the bottom of the ocean and you look at how long the mountain range is for all of these mountains, these ridges under the water, that's going to be like 80,000 kilometers. That is huge. Okay, so now what is this ridge? Well, here's my really poor picture. Now go ahead and look in your book. They have some very nice pictures. You know I can't draw. And this is a picture of a ridge just sort of from the side. And so here's the ocean floor. And we have down here in the mantle, magma comes up and it pushes up through a hole or a ridge in this ocean floor. Now what does that mean? All right, that should make sense to us. We should know that these ridges then have lots of, what is it? Hopefully you said volcanoes, right? Because that's what this is. It's a volcano. So these volcanoes along the mid-ocean ridge, they spit up this magma. And as the magma comes up, it cools and it makes new ocean floor. So right here at the top, that's going to be the newest ocean floor on in the whole ocean. But then when that comes up, that pushes the rest of the ocean floor out and away from it. So we have this brand new ocean floor coming up where the volcano erupted. And those, of course, will be the youngest rocks because we had this this magma that came up, became lava, cooled, became a rock. And that also means that as this gets pushed away, our older rocks are going to be away from the ridges. Now this theory here, this idea, is called ocean floor spreading, and they can actually see this. So once this idea of ocean floor spreading came along, that pretty much goes and talks to this question, how could the continents move? Well, one, the continents are on plates, and we have this ocean floor that's moving. All right, so nothing is staying still down there. It's actually quite active. Now these ridges, if I look at it from the top now, this is like we're flying over with an airplane, you would see a ridge, and then you would see a ridge, and you'd see a line in the middle. And now this should be very, very familiar to us. This is a fault, and it is a transform fault because it shifts it from left to right or right to left. Okay, so this would be just like what we would see if this was a road and we had an earthquake and it shifted it over. That would be that horizontal shift. This is underneath the water called a transform fault. Now, secondly, this idea here. So the magma comes up, cools, and then moves on. Well, what's kind of cool about, or neat, because it's quite hot, about this is when it comes up, all of the magnetic particles, there's little particles in there act just like magnets, all the magnetic particles, when they come up, they're all in the same line. They all line up because the Earth is just one big magnet. And so then when they cool, you have a whole strip of rock that has magnets lined up all in the same direction. And when this happens, those little bits, they form magnetic strips. And that's because, like I just said, the molten rocks, those little magnets in there, they all line up. And then when they cool, they form these strips. Now the neat thing, okay, so think about this. The pattern on both sides of the ridge, so on this side and this side, are the same. So if I have a strip of magnetic stuff here, I will have a strip of magnetic stuff here. So how does that support the theory? Right here I just said it does support the theory. So I'm asking you, how does it support the theory? Don't just take my word for it. Think about it. Why does that do that? Take a look in your book if you're still not quite sure. All right. Now, if we only had this going, then the earth would get bigger and bigger and bigger and bigger, and it would just expand. But we know it's not doing that. So there has to be some place that these rocks go to die, and this is not what in your book. But we come here, and here's our ridge, okay? So we have rocks coming up, but they form right here, and then they get pushed away. Well, these rocks, as they spread out, they come over, and once they hit this continent, then they're pushed down. And when this part where they're pushed down is called a trench. And there's lots of really cool trenches around. And we talked about one, that was that Monterey Trench. Okay, that was, oh no, that was at the 8th graders. Oh, dude, all right, remind me to tell you about the Monterey Trench. I have a great video for it. So the trench is just a big hole in the ground, and these rocks get pushed down into the trench and eventually make their way back down to the mantle. Now this process is called subduction. Subduction, not abduction. They haven't been stolen, but subduction. Sub as in below, and subduction. It just gets sucked right down in there. So then it goes down, they melt. Well, what happens? Well, once they melt, they're going to come over, eventually make their way back over here, and they're going to come back up and become new rock. Now this cycle, this rock cycle, this goes a lot quicker underground, underwater, because of the ridges and the trenches, than it does up on the continents. And this is why the rock in the ocean are all younger than the rocks in the continent. All right, so that's it for 6-2, or sorry, 3-2. Take a minute, fill out your answer sheets, and remember you can always take a look in your book if you aren't sure of an answer. See you next time.